Oh yeah, what's going on, everybody? Welcome to the Artists of Data Science Happy Hour. Super excited to have all of you guys here. It is Friday, April 2nd. Oh my God, how is it April already? Jeez, man, I felt like it was the Christmas party just a couple of weeks ago, but damn, it is Friday already. Friday, April 2nd. Welcome, everybody. Super excited to have you guys here. Thank you so much for joining me. Man, great week today at the Artists of Data Science podcast. Got an opportunity to interview a couple of cool people this week. I interviewed Loris Marini, who hosts the Data damn it, I forgot the name of this podcast. It's the Data Something podcast. I'll get it right. And then also Christina Di Giacomo, who is an industrial philosopher. That was really fun. An episode was released with Super Data Science podcast featuring yours truly. So I hope you guys got an opportunity to check that out. I had a lot of fun recording with John for that episode. So I'll make sure to include a link to that in the show notes. Hopefully you guys got a chance to check that out. Also announced that I will be emceeing the Data Science Go virtual conference. That's happening next weekend, actually, April 10th and 11th. That is actually next weekend. So looking forward to see you guys there. Had an episode released today with Jonaid Iqbal. Jonaid is super cool, man. One of my favorite people on LinkedIn. Absolutely love his content, love his post. So it was really a honor to have him on the show. Man, yeah, a lot of awesome stuff happening next week. Believe it or not, next week marks 1 year since I first released episodes of this podcast. April 8th of last year, I released 12 episodes all in one go. And yeah, I guess since then, just been consistently just interviewing a lot of people, man. It's been one hell of a ride. So thank you guys for sticking with me. I don't know if any of you guys have listened to those early episodes. If you have not yet listened to those early episodes, just don't listen to them because they were not that good. My recent work is far better. So go listen to those instead. But you know what that means? That means next Friday's happy hour session is going to be the 1 year anniversary party. So we should all get ready for that. That'll be exciting. Also next Friday, releasing the 1 year anniversary episode with Robert Greene, author of 48 Laws of Power, Mastery, Laws of Human Nature, 33 Strategies for War, The Art of Seduction, the world famous Robert Greene. Also, guys, be sure to check out the episode of How to Get a Analytics Job podcast, because one of our friends was on that episode. That is Tom Ives. Tom, how you doing, man? Shout out to everybody in the room. Christian, congratulations on getting the new job, man. That is super exciting. I was so happy to see that for you popping up on the LinkedIn newsfeed. Tor, Eric, Vivian, Albert, Susan Walsh is in the house. Congratulations on getting those final words down. Right on, man. Well, welcome everybody. Super happy to have all you guys here. Tom, how's it going, man?
Hey, permission to say an inappropriate thing?
You always have permission to.
Susan, you look so damn sexy tonight.
Yes, that looks like somebody who finished writing a book.
Tom, you've been working too hard. Look at this.
She finished her book. She finished her book.
It nearly broke me.
Man, I got a couple other friends in the house. Shout out to George Faircan in the house.
George!
Super excited.
Hey, everyone.
Hello, everybody. So cool. How's it going, man? So in Canada, we get today off. Today is a day off in Canada. I don't know if you guys in the States get today off either. I think a lot of the Commonwealth nations do for sure. But yeah, it's a holiday here in Canada. Good Friday.
I have some questions. Did you grow up in Canada or?
No, I'm from Sacramento, California. So,
okay, because I was going to say your accent is not. You don't say about weird enough.
You mean like a boot?
Yeah.
A boot in a boot? Yeah, no.
Okay.
I'm from Sacramento. Sacramento, California. Joe is in the house. Joe, good to see you. Antonio. Man, super excited to have all you guys here. Somebody here is from, oh, shoot, it's Auntie, good to see you here. Greg is in the building, man. Nice. This is awesome. Yeah, I'm super excited for next week's Data Science Go virtual conference, because it is literally a Artists of Data Science reunion. Like, that's what they should rename the event, because pretty much everybody who is there has been on my podcast or is going to be on the podcast. So that's pretty cool. I'm excited for that. But yeah, super happy to have all you guys here. Hey, so let's open it up for questions. If anybody has any questions whatsoever, go ahead and ask. And then while that person is asking and you want to hold yourself in the queue, let me know and I'll go ahead and I'll add you to the queue.
I'll jump in. So I have a question that I am fairly certain I'm not going to understand the answer to, but if you can explain it like I'm 5, that would be great. So I have been working on Docker for a couple of hours today and finally making some headway into actually getting it to do something, which is good. But I just don't totally understand the difference between like containers and virtual environments. And I think from a quick Google, I think containers are bigger than virtual environments, but that's about all I know. So if you could help me understand that, that would be super.
So imagine you have like an apartment building, right? So an apartment building, usually each individual apartment in that apartment building might have its own little environment, right? People are going to hang different pieces of art up. They're going to configure their furniture in different ways and whatnot. But they all are going to share some common services, right? Like, for example, each individual apartment's not going to have its own water source or its own heat source or what have you, right? Those common resources are shared amongst all the apartments in that building, right? Likewise, a Docker container is similar to each individual apartment. So each individual apartment is like its own little self-contained environment in a sense, but it's sharing resources with the, whatever, like the PC that it's on. Comparing that to a virtual environment, I don't know if I have an apt analogy for that. I don't even know if my first analogy made sense. I'm going to turn this over to someone far smarter than me who goes by the name of Joe Reese. So
Joe's better.
Yeah, Matt. You here?
Sorry. Yes, I'm on here. I think I just got my video again.
This one, you're like
there you go.
Okay, so
wizard.
Yeah, so a container is a type of virtual machine. If you think of an AWS virtual machine, you get your instance, and it has its own kernel, has a bunch of services, kind of like Harpreet was saying, and it's more or less isolated, right? It shares some machine resources with the other instances on that machine. Now, the problem with that type of virtualization, it gives you extremely good isolation, but having a separate kernel for each virtual machine is very expensive. So the kernel is like it's the all privileged part of the operating system that's allowed to do everything. So it has access to all memory. It manages all the internal processes. So with containers, what you do is you say, I'm going to have one kernel, but then all the other important parts of the operating system, I'm basically going to break apart. So in particular, a lot of important parts of the operating system happen in the file system. So for example, you have all kinds of file system references to operating system components, to executables, to code. And so a container completely isolates the file system. So each of your containers can have its own versions of executables, own versions of Python, own versions of C dependencies. And you also virtualize networking on top of that so that you can minimize a lot of networking problems that you get when you have multiple processes running inside of the same main operating system. So one way to talk about this, if you look up what the userland is in Linux or Unix, so that's your file system plus all the processes that are basically outside the kernel, that's what goes inside the container. And so you can have these kind of virtual machines that are much lighter than a standard virtual machine, get some benefits of virtualization, but have much greater efficiency on top of that. Now, one thing to be aware of from the ops perspective is that there is something called container escape. So standard virtualization does provide a much higher degree of isolation. There are various tricks for processes to get out of their containers and affect other things in the operating system. And so generally, if you're running containers together on a machine, there needs to be some level of trust so that people aren't running malicious code there, because people can definitely do a lot of damage on your Kubernetes cluster if they can run malicious code inside of one container.
I think you're also asking about virtual environments though, right?
Yeah.
Like maybe the distinction between like
that's a good point.
And virtual env. So
yeah,
like virtual environments are typically spun up. You can think of it in a virtual environment as something you would spin up that you would be using, right? So Eric's virtual environment. If you want to start sharing your environments with other people, that's where Docker would probably be more appropriate. So you can think of it that way too. I mean, I assume you're talking about Python virtual environments, right? Yeah. So, and Python does give you the ability to spin up this, just a virtual environment that you can just pip install or whatever installations you want to do in that virtual env. If you want to share that with people though, it becomes a bit of a problem.
Yep.
That's where, Matt's comments about, containers and specifically Docker would be a much better fit. I've worked in environments where it's like people try and share virtual environments and it ends up just being a nightmare for a multitude of reasons. So
And I'll point out one specific case where it's a problem. So with a virtual env, your Python typically still references operating system like low-level C dependencies. And you'll notice sometimes that your Python install of some package just goes completely off the rails because there's something in the OS that you have to have. Maybe there's a dependency that needs to be 64-bit and is 32-bit or vice versa. Containers also package up those dependencies in addition to the core Python code that goes inside the virtual env. And so they contain a lot more of those important operating system components so that you do get much greater portability. To Joe's point, you can ship that container and it will more or less run on any Linux operating system.
So it seems like, just to see if I understood it. So it seems like a container is kind of giving you kind of the best of both worlds of your, instead of working in their local machine where it's not portable, but you don't necessarily have all of the, I guess what you might say is just extra stuff if you have like a full virtual machine, but instead you just kind of grab the pieces you need in the container and then you're able to run whatever you need to do. Is that
exactly? Yeah.
Like I'm five? Okay.
Yep. That's apt. Yeah.
Cool. Thank you.
So kind of just by analogy here, if we needed to circumvent the problem of, well, it works on my machine, doesn't it work on your machine? That's when we would use a Docker container. But if we wanted to circumvent the problem of, well, it used to work on my own machine, now it doesn't work anymore, what did I do wrong? Then use a virtual environment. Is that kind of a good way to think about it?
Essentially, yeah.
Yeah, I think that's good.
Yeah, especially like, for example, I'm running like I have a Mac M1, right? Like, no guarantee that operating system is going to work with a lot of, or the chipset's going to work with some software, for example, like my Intel or so on. And if you do run an M1, by the way, Docker also may not work for you. You have to get the preview version, but that's kind of a sub point. So,
Tom, I saw you were.
I was just going to offer Eric a 3-year-old explanation if he wanted it, but
only if it involves throwing peas as well.
No, but it's like a membrane that only goes one way. Stuff from the operating system or the outside the Python virtual environment can be used inside that virtual environment, but what you put in the virtual environment can't go out to the greater system. And with Docker, it goes a little bigger. Still using the OS and all those things, but it's just a bigger container with the same dynamics. A virtual machine is creating it's a brand new set of operating systems and hard drives and stuff, but it's still just contained at the hardware level, especially if it's a level 1 hypervisor, meaning it's connecting to the bare metal, whereas I know that's a fancy sounding term, but there's just 2 levels of virtualization at the virtual machine level. The second level isn't really touching the hardware directly. So it just depends on how those virtual machine creators are made. But to me, that's the simple example. So Docker is just in between virtual machines and Python virtual environments.
Thank you very much, Tom. Eric, was that a satisfactory answer for you?
Super. 3-year-old version, 5-year-old version, and grown-up version.
Yeah, and graduate version. Right on, man. Appreciate everybody contributing to that. That was really helpful. Thank you. So next question, I got in the queue, I got Greg, and then I got George. George looks like he has a really, really great question, so I'm excited to get to George as well. But I'm always excited for Greg's questions because I always learn something when Greg asks a question. So Greg, go for it.
Well, in this case, I always love building on top of Eric. My question to you guys is, what is the best way to serve a model? Are containers the best way nowadays, the most popular in the best ways and safer ways?
So you mean like
deploying models?
It's a good question. I mean, I use APIs at work. I mean, I just toss it over to my machine learning engineer and he wraps it up into a API, puts it on a Kubernetes cluster, and which also has some Docker with it as well, where it's in a Docker container, and that's pretty much how it works. But then again, I'm not too much of an engineer, so I'll turn this one over to Brandon. Do you need any insight? Good to see you again, though, Brandon. It's been quite some time.
No, what you said is very similar to what we do as well. And I'm in a similar situation as you. I'm not really the engineer, but I work with the engineering team and they do just that.
Yeah. Joe or Matt or Tom?
I was just writing, it's very cultural dependent in my experience. Jenkins is kind of popular. And it also depends on how cranky your system administrator is, whether I think the crankiest ones that are least willing to try new things are sometimes the best ones because their crap doesn't break. So, but if they'll let you use Docker, that's great because it's so easy to deploy that way. But I think it just varies from place to place. There's no wrong answer either.
What kind of model are you talking about? Like what makes, is there a framework that makes the model, or is it?
No, any machine learning models in general. Is there a go-to framework that is popular, safe, easy to plug into, or something like that? What is the?
Yeah,
is it,
I think there actually are. So I think to Tom's point, it's a very broad question. Like the answer is kind of it depends. But if you make a model, you can deploy it. Say you're in the clouds, like you're in AWS. SageMaker is a perfectly viable way to do it, and I would totally recommend doing that versus writing like a Flask API in AWS, for example. If you're using TensorFlow Extend will serve a model just fine. PyTorch has a very equivalent thing. If you're doing sklearn, like if it's a job or pickle file, I guess you can throw an API behind that. But if you have the advantage of using a hosted service, I would use that. It's actually just talking to somebody from GetNeuro.ai, I believe is a company. Actually, Greg and I were chatting earlier. It's actually that YC company I was telling you about. So they have the ability to just write a model and host it. So that's kind of cool. You're starting to see a lot of good frameworks come up starting to address this problem, sort of end-to-end ML ops type stuff. So
I guess that the it depends part is really dependent on how you want it served. Like, how do you envision the person who is going to be using the results of this model using the actual results, right? Like, are they just going to a website, entering information? Is it integrated into a much larger system? Like, how, I guess that's where the it depends really matters, right? So maybe that could help if you have any idea.
Yeah. And behind my question, I was like, kind of, are Docker containers a go-to way, a safer way to go about it? Is it the most popular? What makes them so powerful? That's with regards to deploying machine learning. That's what I'm trying to understand with regards to Docker container.
Yeah, I'll turn this one over to Matt, but I want to make sure Matt corrected me if my understanding is incorrect here. But I think the great thing about the Docker container is just reproducibility. Like, you don't even need to worry about wherever this thing is being hosted. You don't need to worry about installing all the necessary packages and recreating the computing environment from scratch. Everything is there, like as you need it. Matt, is that a good interpretation?
That's a good interpretation. It's combining reproducibility with scalability. And so in some sense, what containers allow you to do, so if you take like the AWS Solutions Architect exam, they spend a lot of time talking about auto scaling with virtual machines, which again is a way to get reproducibility. You can have a VM image. The problem is that's pretty coarse-grained scaling. And so containers you can think of as allowing a smaller unit of compute. Say you're presenting an API for machine learning model evaluation. You can scale up gradually just by adding one container at a time, and the cluster itself scales up more closely. And then often the other trick we'll use is you can have that Kubernetes cluster host multiple types of workloads to sort of even out the loading on it. And so you could even host things like machine learning training with your machine learning model evaluation in the same cluster, and then gradually just add more containers as those workloads vary. So if you suddenly have a huge workload for your training, the cluster can scale up. As you get more hits to your site, your evaluation models can scale up as well. So, but yeah, reproducibility is one of the main drivers for that. And I think the thing that led Google to research containers in the first place.
Yeah, it's sort of the argument. Have you heard of the argument of like pets versus cattle? So, I mean, think of like a server has like a special server is like a pet. Like you love it and feed it, and it sometimes dies. Cattle are basically like, they're not your pets. I hate to be crude, but they're expendable resources. So you got to think of containers that way, right? So, it's an image of something that you want to do. And you can spend as many as you want or kill them all off. It doesn't matter. So
makes sense. Thank you. Thank you, guys.
All you have container, like Docker container technology, I could look that up, but this concept of containerization, like, does this date back a couple of decades, or is this like a relatively recent?
Pretty old, actually.
Yeah.
The concept, goes fairly far back. Like people can identify antecedents from some microsystems and others. But I think Google introduced two main commits into the Linux kernel in like the early 2000s that introduced containers. And then as far as popularization, that really happened because of Docker, where people said, hey, this thing Google is doing is really cool. Let's get it out there to the wider public.
Just precisely because of the reason, like, people mentioned hypervisors before, right? And like that's just utter pain in the ass to deal with. So, So Docker changed a lot of stuff. Because I remember the days when you had to spin up VMware and just the world's a better place now.
Yeah. Awesome. Well, thank you very much, Greg.
Can I add something here?
Yeah, absolutely. Please do.
Yeah, one thing that helps in our team is we have a lot of team members, like around 10 that are developing the same app, and the Docker stuff lets us all have kind of the same environment to work with. So we'll have the Docker file in the Git repo, and then we can respin it if we want to, whether it's on a VM or sometimes in your local machine if you got to do some special testing. And then it also helps us to track it too, right? I can track the Docker file across different versions if we need to find out what changes were made last week and somebody installed a new package or something.
Thank you very much. Appreciate that, Brandon. Greg, was that helpful? Awesome.
Good to go. Thank you. Appreciate it.
All roads lead to Docker in the last couple of questions. So we'll keep that thread going. We'll find a way to interleave it to George's question.
Yeah.
I'll blame that on Eric.
All right, guys. So next I got George. And then after George, I've got Nisha. And if anybody else would like to put themselves in the queue for a question, just shoot me a message and I'll add you to the queue. George Farrakhan, my friend. Good to finally see you here. It's been quite some time. How you doing? And excited for your question.
Always happy to be part of these. Luckily, it's a day off for me, so I'm able to join. So hooray, you're putting always great content in. So thank you, everybody, for your time. Yes, Joe, I'm moving away from the Docker question and answer here. More on the business side, I was wondering, how do you best integrate data scientists in a company? Is there such a thing as that golden rule, the golden framework that any company should adopt? Should you have data scientists as part of one central unit and provided as a service? Everybody should be treated as a data scientist and be taught as such? Should you have data scientists within a particular business unit? And there's different other models, and I put a couple in the question in the chat there. So I was wondering, from your experiences, what's that framework looking like, where you, as a data scientist, you found out that you were able to contribute the most, and also the business benefited the most out of it?
I'm excited for the discussion that's going to come from this. Let's start with Antonio.
Sure. So right now, I'm not a data scientist, but I work more on the AI strategy place. And we literally, my company. So I think whenever, if I could just ask for people when they answer this question, if they could kind of talk about how big is their company, because I was literally today about to ask the same thing, because this is what I've been dealing with at work. So I work for a Fortune 50 company, a lot of teams, and we didn't have a data organization, no chief data officer at one point, right when I started. So it was very kind of that spoke model, or as you said, decentralized. Each business unit had a data scientist. And what was a good part of it was a lot of things. I was very familiar with the business, right? We interacted one-on-one. So those things were kind of getting done. The negative side of that was, for me personally, I didn't have the best access to the talent as a data scientist, right? You can't know everything. I didn't have the best engineering. So when we would have to put something like a model, we would just okay, let's send these results to SQL. You can read it from there, kind of just put things together, right? Because if you're a data scientist, doesn't mean you're a great engineer. So that was a negative. And then what happened, another problem that I saw once I moved over more to the strategy role, is when you have the data scientists all in silos, you have a lot of people doing different things, and you don't have that kind of one source of truth. Everybody's doing their own thing. People are using different tools. So that kind of becomes messy as the organization scales. Since probably last year or so, my company has hired a chief data officer. It has put a lot of the data scientists, probably 1,000 data scientists under the CDO. And we have engineers, architects, and all of that. And what's been great with that is when we have high visibility projects, we're able to get all of the smart people in the room. Like, all right, give me the best data engineer, give me the best architect, give me the best data scientist. Let's all sit together and work on this project. So that has been great. So I haven't had to struggle with, kind of like scrapping talent and begging people to work on things. So that has been a big plus for the business. And we also, it helps with data governance. We have like a AI center where you have the same rules like explainability. You want all AI to be explainable, and you have everybody to follow those same guidelines. And that has been great. Data taxonomy is starting to get standardized. So you kind of have those things across the silos. People are talking the same language. It's been great. The reason why I was going to ask this question today is because now that we sit away from the business, that is the negative part, is we're a little bit distant from it. And what we've been trying to do is, okay, invite us to your meetings, right? Which they try to do. It takes time, right? People have to gain your trust because now you're not on their team anymore. You're sitting somewhere else. But people have their own meetings. They talk. And by the time they come to you, they're like, hey, we need this model. We want this model built. And you're like, well, I don't think that's a good idea. They're like, well, we just spent 3 weeks talking about it, So you're like, well, if you invited us in the beginning, we wouldn't have spent 3 weeks, So that's kind of that problem. So we have I call it a hub and spoke, kind of that hybrid model where you have the big projects and like the data scientists and engineers on like centralized, and then you also have smaller teams across the business. I think that works the best. At least it's been in my experience. But I think it takes time, because once you're centralized, you have to gain the business's trust, and you have to meet people, and it's been on calls every day, and I think it's a lot harder working from home. When you're in the office, you at least see people, compared to when you're at home, like people don't just give you that trust over an email. So it's been a lot of meetings and such. So I know that was a lengthy answer, but I'm literally going through this stuff every day. So wanted to share my experience, and I would love to hear what works for other people.
So quick question. When you said thousands of data scientists, was that like legit? Like that many people?
No, so so I work at Verizon. Verizon has like 100,000 employees. I know a lot of them are retail, but in the corporate, there's a lot of employees, and we have more than 1,000 people that are with combined data scientists and data engineers. So yeah, it's literally like, if you look at just that department, it's probably like a mid-sized company.
Wow.
So it's a lot, but then that's why you see everybody has different ways of working, and you're just trying to how do you make everybody be on the same page? It's a challenge, but it's a good challenge.
Yeah, definitely. Like I'm going through very similar challenges at my current company, being like the first data scientist in the organization, and now having to create kind of like a data strategy for the organization and trying to think about what is the best way to build out a quote unquote data group or a data practice. And, we've done a little bit of research, and we're moving towards or conceptualizing at least the center of excellence model, which is kind of what we're moving towards. But let's hear from Brandon Quach on this one. Antonio, thank you so much for that.
Yeah, thanks, Harpreet. Right now, I'm working on an integrated team, which is we got about 3 or 4 data scientists. We have 2 or 3 data engineers, 5 or 6 software engineers, business analysts, and we don't have a central data science formal organization in our company. So I work at Teradata, publicly traded. I don't know how many companies. I would say it's a medium to large company. I've gone back and forth with a few of my colleagues about this as well. And I think I'm not sure if there's a really right or wrong answer here. I like integrated teams just because I've recently been working on them, and I had struggles before. For me, the main thing is that people tend to do what their boss tells them to do. And if their boss has KPIs, then everybody's concerned about getting their KPIs up. And the reason why I bring that up is I've been in other organizations where it's more of a throw it over the wall model. And just to tie it up with the whole Docker thing before, because that's like my duty now. I was working in an even funnier environment where it was like a firmware SaaS software team. It was an aftermarket device. My machine learning models were built on MATLAB and had to be compiled to C and plugged into there, right? So there's no fancy VMs at all. It's just like an aftermarket device that you put on a car. So there we had to work with the engineering team, right, in order to get our models into production. But they had different issues, right? They're working on, issues with CPU usage and memory usage and a whole different, they report to a different person, VP of engineering, and it was hard to force anybody to do anything. And the moment I got into follow-up questions, they stopped me and said, you know what, you're going to have to write a Jira ticket and we're going to have to prioritize this along with everything else. You can't just come to my office and asking for like hours at a time. So that was difficult for me. I've been in even a consulting organization where we had the shared resources, right? And one funny thing that kind of happened there is people know who the good people are. And then there seems to be a way where in between projects, the good people are on these like funny temp projects. So then when that next SOW gets signed, boom, they got you on the real project they wanted you on, things like that. So I think in the environment of big organizations, you have issues like that. But I would love to hear people's arguments for having a centralized. Oh, and then one last thing I'll say is the way that we kind of get that communication going on among the other data scientists. We just host things like data science, kind of like office hours, just like this, right? And every Friday at 11 a.m., all the data scientists, whoever wants to join can come. And then we just exchange ideas there. We don't report to each other. We don't report to the same person, but we exchange ideas there.
I really like that integrated type of idea because I think it just makes for really more well-rounded teammates if you can really understand what people are struggling with and what their concerns are with whatever it is that you build. I like that idea. It makes for more holistic I don't know if holistic's the right word, but it just makes for a more well-rounded, I think, data scientist. So Tor, I see you have your hand up. Do you have a question or comment on this topic?
It was just a comment because this is a very common problem in any industry when you have set up specified departments with specialists, etc. To me, one of the key things to get involvement to avoid potential processes where people have been working for 3 weeks and of course then they come and ask you and then it can't be done or some problems. The key thing is really to look at your own workflows internally in the organization. I'm a true believer in the concept of like advisory board, or you set up representatives of different parts of the organization, whether it's like a group of data analysts, you have one person that's key, contact person, one for the analyst. You may want to have one for the IT. You kind of have an advisory board. And when you have larger projects, you will then, of course, include all the key people in the process at a certain part of the stage. I'm not a believer in big meetings. I hate meetings, to be honest, myself. Meetings, they have to be efficient. They shouldn't last more than 30 minutes. But for me, the key is to get the right person in at the right time in the workflow and in the work process. And how that is managed, that means you have to sit down in the organization, have a strategy, an overall strategy, and then you have to look at how the organization is operating. Once you figure that out and how your processes are, then you should evaluate each individual project based on risk levels, the impact, the low fruit, high fruit, whatever you want to call it, and you have then generated a pipeline. Some projects need to go have a much larger involvement from more of the organization. Smaller projects should have simpler processes to follow. But however way you look at it, they need to include the people that could potentially have an impact on the end result, whether that's a data analyst or a secretary or cleaner, whatever it is. That's my philosophy on this.
I like that. It makes a lot of sense. Russell, would you like to add in here? And after Russell, if anybody else would want to speak on this topic, let me know, and just let me know in the chat, and I'll call on you. Otherwise, after Russell, we'll move on to the next question from Nisha. But Russell, go for it.
Sure, thank you. Evening, everybody. I'd say very generally, and more from a business perspective than from the data science perspective per se, that I think it's going to change depending upon the business. If you've got a very niche business that does one thing well, regardless on the size, really, I think that'll lend itself well to having a centralized data science unit that can then feed out to all of the various arms. If you've got a variable business that has lots of different centers, either geographically based or actual actions. For example, the business I work in does lots of different things in lots of different fields. It just wouldn't work for us. So whilst I work within business analysis, data science, etc., and funnily enough, I am centrally based, but I then jump around a lot of places and liaise with a lot of people. I don't think one centralized arm to do everything would work for us. but perhaps a hybrid model. So you've got a centralized control unit that then works as part of a network with satellite centralized subdivisions within the other divisions of the business. So I suppose a long way of saying it really depends on the business.
Yeah, so it kind of sounds like that hub and spoke model that Antonio was talking about a little bit earlier. Tom, I'm curious that throughout your career, how have you seen the most successful data practices, data teams structured?
I don't think it depends on structure. Harpreet, I think you gave the best one word answer: integration. It's really about how much the data scientists care about each other. Care to help each other serve the organization better, care to help each other learn what they need to learn to get each job done, care about being humble enough to go ask for help, and not having a fear to go ask for help. We don't know it all. Sometimes we knew something really well and haven't used it for 5 years, and we just forgot it even existed sometimes. So I think a very nurturing, kind, gentle, patient culture that's integrated and always wanting to help each other put data science on the best footing in the overall organization. So what I'm saying is I'm structure apathetic, but integrated culture and carrying culture to the max.
Awesome. Thank you very much, Tom. I like that. Fits well with the kind of the organization you're in, the integrated machine learning environment. George, was that at all helpful? If anybody else wants to add in here, either Joe or Matt or Greg, or anybody for that matter, go for it. But
I actually have a follow-up question for this specifically. So I was doing an informational interview with someone who's at a much larger company. For context, I'm at a 60-person startup. The person I was talking to was a data science leader at a 20,000 person company. And I was discussing my strategies where I would talk to business stakeholders all the time. And that's how I stay in the know and stay integrated. But what he told me was that at the scale that he's at, that strategy would not work because a lot of the key decision makers are like these VPs who only have 5 minutes and it takes 3 weeks to schedule. So that strategy wouldn't really be purposeful for me or probably hinder me. And so with this kind of thing about where does this data science team sit and kind of integrate with the rest of the companies, what is there a certain point where you have to be more strategic with talking to people, or is it just you have to put yourself out there? This conversation kind of reminded me of that conversation I had last week.
So can I distill that question down a little bit? So is the question about strategy and strategic communication? And maybe I missed the question there. Sorry.
Yeah, the question was a little raw. So from what I'm hearing from this current conversation is that how should we set up a data science team, this hub and spoke versus, being a centralized place. And from what I got from that is the key components communication and business needs, what should we work on? And so as a smaller company, I'm able to just do that very easily. I just go and talk to people. But when you go to a larger company, that's not maybe the best strategy. And so is it the team structure design that's really important? Should you just be not aggressive, but be a go-getter and just talk to people? What's the best strategy for data scientists for navigating these larger companies?
Yeah. Oh, Greg, go for it.
One thing I always see companies forget to do is to self-assess where they are. I remember, and I was pulling the document trying to remember where I found it before, and I thought it was so good. Maybe I'll share it with you guys. It's kind of making an assessment of where you are in terms of some sort of AI maturity matrix, and then work from there to figure out where you want to be in terms of how you want to position your workers, because it will give you a little bit of idea of where you are in terms of AI. So the matrix goes from exploring, experimenting, formalizing, optimizing, transforming, and then this, you have different your people, your processes, et cetera, and you kind of strategy, data, technology, or governance, and then you kind of gauge yourself for where you are. So if you're a company that's experimenting, and then you kind of have a feel for who are the people that you have who can excel or who can perform that experimenting in AI, then you can kind of position yourself in terms of whether you want a centralized team or you want to dispatch, do you have enough people per department who can perform that experimenting of AI, and does it fit the business needs going forward? So it's always, easy to say, oh, we want to go after that, but companies have to do a self-assessment first to understand where they are in that, spectrum of AI to know how to move forward going from there.
I tend to agree with that. And also it depends, if you're doing data stuff at all, like if you aren't, it's probably better setting it as like a Skunks Works project, actually, and not getting the rest of the company involved just yet. And so, but if you're Amazon, you've been doing data since day one. So it's like, that's just part of the DNA of the company. So I don't think there's like a right answer to that. And it's also this weird dichotomy between like the hub and spoke or centralized model, right? I mean, because I think there's pros and cons of both, but what I've also seen successful is actually a combination of the two. Is you react in one way or the other. It's a weird trade-off. Centralized means obviously it's very command and control. Hub and spoke means that you run the risk of having silos, right? And then practices and everything else sort of gets out of control. So, I mean, and there's a third option is just kind of do both at the same time. But, I put a link in here to Conway's law. I mean, it's sort of the immutable law of organization. So you're going to design systems that represent how your organization communicates. So if you're very much a command and control company, like no amount of hub and spoke is going to save you. Like it will not work in a company, period. And like same the opposite. If you're a very decentralized company and you try and do a command and control, that ain't going to work either. So this depends on the organization, and but most of the time I think you'll find too that like these cultural and organizational things, they've accidentally happened. Like I don't think a lot of people are that intentional about creating culture or ways of communicating. So just organically happens, and then I guess you get to deal with whatever that is. So,
Mark, did any of those responses answer your question at all?
Definitely no. I really appreciate that. Especially, I really like the Conway's law. I already put in the chat. I'm gonna share that with my manager, and also like that strategy component as well. That was really illuminating.
Right on. And Mark, I got to holler at you about getting me in touch with Liz Fosseline, because I'd love to have her on the podcast one of these days.
She's my favorite. I can go Slack her right now.
Awesome. Thank you. Like I'd love, like her book sounds awesome. I want to read it and I want to talk to her about it. Cool. Thank you. Nisha, you are up next. And after Nisha, I've got Saurabh. And then after Saurabh, I've got Austin. And if anybody else would like a question, shoot me a message, let me know. Oh yeah, and Joe's saying John Thompson's book on analytics teams. Yeah, great book. Definitely check that out. Building analytics teams. I think that might help George and Mark. I know it's helped me. Yeah, I've got an interview coming out with him at some point in the near future, so keep an eye out for that. But wait, I got to first verify and see, George, your question. This all sprang from your question. Was that? Oh yeah. Thank you, and thank you, Brandon, for mentioning Docker and not ruining the pattern so far. Yeah, dude, George's course has been. So I've been going through a lot of George's stuff online just because of what I'm working on at work currently. George was nice enough to give me access to one of his courses, and it's been immensely helpful. I'm super excited. I think we're speaking on the 12th, so in just about 10 days. So excited to chat with you and have that episode shared on the podcast. Let's go to Nisha.
Hey everyone. So I had a question about the different scaling techniques that are usually available and need to be done before performing a PCA. So I am working on a project for my thesis, and I'm trying to find references as to which scaling is there a specific requirement that one scaling technique needs to be done, or different articles in my domain says different scaling techniques, but they don't give the reason as to why they are performing one scaling technique versus another. But most of them seem to do a standard scalar technique, which is just mean zero and unit variance. There are other techniques some other articles use, and I'm just wondering if there is a reason why one would do one scaling technique versus another, especially before performing a PCA. So if anyone has any insights, I would much appreciate it. Thank you.
Yeah, I think different scaling techniques really depend on how you're going to be using the data downstream. Some algorithms will have assumptions that data should be scaled in some particular way. So I think that's one piece of it. For PCA, if I'm not mistaken, I'll turn this one over to either Brandon or Thomas, but if I'm not mistaken, for PCA, you should standardize before doing the principal component analysis. Standardize in the sense that, unit variance and mean zero. Brandon or Tom? Brandon, I don't know if you're frozen.
Yeah, it's been too long since I've done this. I forgot if PCA you absolutely need to or not. But if you did, then the first thing I would do is check out the distributions of all the input variables, because sometimes you'll just get like funny distributions and you're like, what does standard deviation mean here if I calculate this and I'm going to divide it by it? And then sometimes you'll have like bimodal variables, or you'll have like categorical variables. And then you have to think about how do I transform this into like something numerical?
So in my case, everything is numeric, and I do have to do scaling because one variable is in terms of units and the other one is in terms of dollars. So there's a huge variance. So I am pretty sure I need to do some kind of scaling. I'm just confused as to why some articles say we should do a standard scalar scaling, and other articles say we should do a min-max scaling. Is that a personal choice, or is that because of some criteria that I'm not seeing and it's not mentioned and it's so obvious to the people who've written the articles?
So again, look at the articles and see what is happening downstream of that scaling, right? Scaling is just one step in the process. So in your particular use case, like what is it that you're actually trying to accomplish with this idea?
Once the scaling is done, my goal essentially is to perform a logistic regression analysis.
Okay.
And the domain that I'm working on.
Yeah, you don't need to scale anything for logistic regression. You just leave the variables as they are.
The variables are dependent, and so my advisor was telling one of the requirements for regression analysis is they are supposed to be independent. And one way to do that is do principal component analysis. Mm-hmm. So you get that dependency part out of the equation.
Well, there's easier ways to get rid of dependency. Maybe you have collinearity present in your feature space. So I would advise doing feature selection before doing any PCA, right? So meaning, did you compute any variance inflation factors? Did you see if there was any features that were linear combinations of other features? Did you handle that?
Yes.
And once all that's taken care of and you've absolutely reduced down your feature set through feature selection, then look at, mentioned variance inflation factor, but then maybe look into PCA. But then you're going to lose all interpretability when you perform PCA and then try to do logistic regression on that. So, it just depends on how you're trying to use it. So how many columns are you dealing with? Features are you dealing with?
200.
200. Yep. So of the 200 features, did you start by eliminating columns that were low variance? Did you start by eliminating columns that were possibly linear combinations of each other? Did you start by looking at maybe doing some type of variance inflation factor? I keep saying that because that is key to reducing collinearity in your feature space. Did you do any of those steps first?
Yes. So these 200 features are essentially narrowed down by the domain experts from a lot more set of features. And these features are created in a manner of roll-ups, meaning this is the data that I'm working with is kind of transactional data, and I'm rolling it up by some criteria.
Yeah.
To look at a specific, so each row represents one specific item. With regards to variance inflation factor, the domain experts say I should try to, to explain as to the VIF, essentially, they are not very happy, and I'm in an academic setting, not in an industry setting. So the thing that they are saying is that I should start with all the 200 variables and then narrow it down. Interpretability, when it comes to PCA, what they're saying is that you still can, based on the principal components, you can still make an observation as to these are the variables that are associated with the first principle, second principle component, and so forth. So that's where my dilemma lies. And I was just hoping to get some idea as to what people do usually.
So, that crazy type of dimensionality reduction, to me, it's always like a last resort. I mean, if once Tom gets back, if he gets back in time, I'll turn it over to him for that. But I'm more inclined to do just more highly interpretable things. So if you have 200 features, you've done your feature selection techniques, you've examined various inflation factors, my next logical step, being a simpleton, would be to start looking at possibly stepwise feature selection, right? Maybe start with one feature, incrementally adding one, or start with all of them and start incrementally reducing some, or maybe doing some type of feature selection where I look at, again, some type of correlation threshold where I look at features that are correlated with the target and then find groups of features and then try pockets of that feature space and compare those models all across and see what happens. I'd do all of that stuff before I do something as drastic as PCA. But then if I was to do PCA, I would make sure I just standardize unit variance, zero mean. That's probably how I would proceed in this case.
Okay, so is there a reason you do a zero mean unit variance before PCA? Maybe I should pose it that way. Why not just scale all the variables between 0 and 1, like a min-max scalar or a robust scalar?
Yeah, so for PCA, you think about what is it that PCA is actually doing. So PCA, you have to compute like eigenvalues and eigenvectors and things like that, right?
Yeah.
So if you're just scaling those values between 0 and 1, like that's essentially the same as leaving those features untouched. You know what I mean? Because you're just moving it to a different scale. It doesn't really help with the computational burden, right? That's my understanding of it. So maybe that's just the way I was taught. I would make a unit variance, zero mean before doing any PCA. But yeah, I mean, other than that, I don't have a good explanation. I see Joe's unmuted, so maybe he might have some insight here.
No, I just unmuted myself. I don't know. Yeah. Matt, you used to teach math. I don't know if I want to throw you under the bus on this question.
I mean, honestly, I've taught linear algebra and other things, but I'd have to brush up on PCA in factor analysis and some of these other techniques to give you a good answer. So it's been a while since I've looked at any of those in detail. Maybe another week I can have something prepared.
Tom, when we need him.
Yeah. Tom is he's disappeared for a second.
But I think, can I add something? I think it's telling, right, that you have a room full of data science professionals who can't give you like a straightaway top of the head answer, because that's a main difference between academia and working in industry. Like it's been a long time since I've tried something as crazy as PCA, which in academia isn't crazy at all. It's well established and old and simple. And but if I were to go to a business person and say, oh, the reason why your credit was denied is because these three components somehow map into this other dimensional space, and like nobody's going to buy that, right? They just want to know that, oh, you have more than 3 credit cards. That's bad. Or you open a credit card in the last 30 days, that's also bad.
I mean, when I used to build feature engineering and feature selection tools for AutoML, and like the things you'd want to watch out for, I mean, the main things you want to watch out for more than anything is just if your features are correlated with your label, right? That'll seed your model faster than anything. So that's the first thing I would look for, is just ditching that. Then obviously, trying to figure out which features are redundant, toss those out. PCA is definitely a last resort. I don't know that you need to go that far. Because if you reduce your subspace down to 3 features or something like that, I mean, you could, but I think you're going to lose a lot of fidelity and interpretability as well. So, and most of the time, I don't think you need it. The structured data process, especially when you're doing logistic regression, because again, you want interpretability, but with PCA, you're going to actually compress the feature space down to the 3 components that have the most variance, right? So it's really hard to do it. It's hard to get interpretability off of that because you've done a compression at that point.
Yeah, and that's actually the key point for why you should do unit variance with mean 0 before PCA, is because of all that those different variants that each column can have. Like those scales for those variants can be wildly different. Right.
Yeah.
So that's.
Yeah, I mean, and this is like the crux of just structured data problems in general, which is why you don't see AutoML with structured data is not as successful as image recognition or NLP, precisely because you're dealing with tabular data that has no rhyme or reason to it at all. It's just numbers thrown into a spreadsheet or a database table, maybe combined, but it's not like there is no sense of coherence to this data, right? And then when you talk about scaling, for example, there's, choose how you want to do it. There's, it just depends on how the data is distributed.
Yeah,
so.
like if when I have features and I need to compute some type of distance between features, and those features are all on these wonky, weird scales, then I would opt for, some type of scaling between 0 and 1, because that makes sense in that case. So I guess that's kind of like my intuitive approach for using one particular type of scaling versus another. If I'm doing some type of distance computation, then yeah, I should probably make sure everything's on the same scale. If I'm caring about doing something that involves variances, then I'd probably do univariance and zero mean.
It also depends if you have a normal distribution with your data as well, right? If it doesn't, then mean zero scaling isn't going to be that good for you. So.
Can I ask a quick question, Nisha? If depending on how much you could say, what are you working on? And then having context is important sometimes. And this 200 variables predictive? Are they useful, or are you? Yeah. What are you working on?
So the 200 variables comes from domain experts. They essentially say that these predict I'm working on a fraud problem. Essentially, I'm trying to predict which provider is committing fraud. I'm in the healthcare space. So these 200 variables, and we know for sure that they are correlated because these variables are like the mean amount that are being paid for a provider, the standard deviation of a provider, what's the median, what's the third quartile. So we know, obviously, that the mean, median, and quartile for that provider from each line level transaction that happens are going to be related. So, but at the same time, if a mean of one provider is very similar to another, but the third quartile is very different, then something's different about that provider. So I'm trying to target those providers who are different. So I do need the mean. I do need the third quartile as well, even though they are related. And the 200 features, it quickly blows up to 200 when we do this for let's say, just one variable. If we start with, it has a mean, it has a quartile, it has a median. And that's kind of, if you think about it, a box plot kind of way to figure out how does the distribution look. So that's how this problem is being approached currently. And the initial set of variables come from domain expert. Hope that gives a background of what I'm working on.
Yeah, that does.
Why I'm trying to reduce the features.
Yeah, so I think feature selection is probably going to be a better bet than dimensionality reduction, just because sounds like you're in a context where interpretation matters a lot. And just like what Brandon was saying, try to explain to regulators that whatever this first principle component indicates that we shouldn't give you a loan. They're like, what the fuck is it? What's this have to do with anything?
So I understand the interpretability part. So the way that I am addressing that interpretability part is that from a principal component analysis, I can say that these are the variables that were related to the first principal component, and that's what I'm counting on.
Yeah.
So I'm not completely losing the interpretability part. The reason I'm not doing feature selection is because if I do a feature selection, I'm going to lose that feature being divided into mean, median, quartile. Only one of them is going to get selected. And that the small variance between the mean and the quartile third for a particular provider is kind of lost. I did try that as well. It just didn't work as well as my logistic regression, I guess, in a principal component analysis setting. But I'm still working on it since it's my thesis problem. I have a long way to go.
Yeah. So we're just, this entire time we're stalling until Tom came back. So Tom, we need your help with some PCA stuff. And I'm going to just step away for one quick second. So Tom, Nisha, have at it.
Hi, Tom.
Forgive me. Yeah, I had to go pick up a child, so I need more context. I have a question about different scaling techniques that are available. For example, before doing a PCA, are there reasons as to why one? So I think, I'd use, and I can't ever remember the exact names, but the stuff that uses quartiles, I tend to use that if you have some horrible outliers, maybe. But you want to try different ones just to see how you do also. But was there some question around if you should eliminate some features?
So the question was more regarding to, in my case, I'm working with about close to 200 features, and I'm trying to reduce them. and I've gone down the path of doing a feature extraction rather than a feature selection. So I'm doing a PCA. So in my domain, the literature says, okay, there are different techniques that before doing a PCA, we obviously want to see if all my variables are almost on the same scale. In my case, it's not. So I'm doing a scaling of each variable before I do a PCA. But the question comes as to which scaling technique should I use? The most common one seems to be the standard scaler, which is the mean zero unit variance. But there are other techniques that are being used as well, like the min-max technique, scaling each variable between 0 and 1, versus a robust scaler technique, or I think the interquartile technique.
Yes, interquartile. So
I'm just wondering why
PCA,
how would one decide?
Yeah, so I wouldn't stress too much over which scaling technique to use, but what I would do is look for collinearities first. And then among those features that are collinear, you can keep the one that has the strongest correlation to your label or your labels. Does that make sense?
Yes. So my problem is I know there is collinearity and I cannot remove that collinearity. So for example, one record essentially says, okay, I have a hospital provider and their mean number of clients is, or the mean number of people that they are providing service to is about 100. And the third quartile is about, let's say, 300. And there's another provider who has the same mean, 100, but their third quartile is 1,000. And that's a questionable provider just because their third quartile is much different from most of the providers of the same range. So
are you saying you cannot get rid of the other features that are collinear with the strongest?
Because it adds value
feature?
In my case, right?
Okay.
But does it add predictive value? It might add descriptive value, which is fine. Like you can use whatever features you need to describe a situation. But if it's not contributing to a useful prediction, then you could toss it out for predictive purposes.
Exactly. And then you can hang on, Nisha. What Harpreet was saying was correct. It's what I was about to get to is just because don't think for the predictive model, you don't need to maintain all the features. Now you can still correlate the one that you kept to the other ones. But it's kind of like if you try to keep them in on the prediction, it's just going to cause you mathematical issues in a lot of your models. Now, I could be wrong. I've never tested this, but I'm pretty sure that if you use one of the tree methods, like basically decision trees, random forest, boost methods, I think you can get away with collinearity then.
You absolutely can. Yeah.
And so that way you can keep them. But if you still want to reduce some of those features, just get rid of the collinear ones that you can get rid of. Then look for ones that have like nearly next to no correlation to your labels, and then throw those out. And then once we're kind of flopping back and forth just for the sake of reducing features, going ahead and keep that one biggest feature among the collinear features for the sake of finding other features you can take out, and then run PCA on the rest of it. And then your bottom liars for PCA, the weakest eigenvalues, you can throw those out at a certain level. And then Nisha, you can even test with, use that as a triage list. Okay, I'm going to keep these with high eigenvalues, these with low ones. I'll experiment adding them back in until I start to see a difference in metrics that you care about. And then when you see that dropping them off is not changing your metrics significantly, that's a good place to stop including features. Is this helping?
Yes, but my question was before the PCA. So the scaling techniques, right?
I think I mean this very nicely. It may not, I'm struggling to come up with a nice way to say it. Don't stress too much about which scaling technique, but start with min-max. If you've got some bad outliers, just start with min-max, see how that does.
Okay, cool.
The general rule of thumb is you're going to use, a Gaussian scaling when you have Gaussian distributed data, right? Otherwise, min-max will work just fine. And
yeah.
But then 200 features isn't even that money. I think you could probably just throw it in and see what happens. So.
And Joe's right, but if you can run each of those features through a Gaussian tester to make sure it's approximately Gaussian and it's okay to use it that way, that's a good thing to do too.
Okay, cool. Thank you.
By the way, on integratedmlai.com, there's a blog post by Tina Mary, and it talks about these kind of things, and testing for Gaussian distribution approximation is in there.
Awesome. Good kickoff for a great discussion. Thank you very much, Nisha. And I mean, to Brandon's point, you got a group of data scientists here, and all of us are just coming up with different answers because this is, it's not easy.
But there's
who's forgot all this stuff. He's probably forgotten more math than we all know. So.
There's an art to it too. And Nisha, you know what? I bet what's going to happen. You'll try min-max, you'll try standard, and you'll go, oh, they didn't make that big a difference. That's what I'm guessing you will find. But you might come back and go, you idiots, it was this. And I can't believe how bad y'all advised me. Darn it, I'm never coming back. I don't know. We'll see what happens. We'll hope for the best.
It's worth the price of the admission, though. So
ultimately, my advisor has to agree to whatever I do, right? Otherwise, she's not going to let me get a PhD, right?
Is your advisor a statistician?
One of my committee members is a statistician.
Well, just make sure that
my main advisor is not.
What are you getting a PhD in?
Health economics.
Oh, well, then just talk to the statistician and use the statistician's methodology and forget everybody else. This is me as a statistician being biased. Anyways, thank you very much, Nisha. Great question. Saurabh had a question, but he bounced out. So let's go to Austin.
Yeah. Okay. So my question was it was sparked from an earlier question when we were talking about the different models for how you position your data science teams. And it was really about when should you start looking into getting a potential chief data officer or someone who can help kind of determine your overall strategy. Because right now in my current company, we're kind of working on this where our data team is working with IT a bit more, but we don't have anyone who's holistically looking at the strategy. And so I'm just curious what other people think, like, how should you approach that?
Man, that's a good question. Anybody want to take a stab at that? If my boss is listening, it's time to get a chief data officer because I need a raise. So now's a good time. But yeah, if anybody has any.
Would you rephrase the question one more time?
Yeah. So when should you bring in someone who looks at the strategy and more holistically? In my mind, I was like, we were talking about chief data officers earlier. I know Harpreet, he's kind of leading the charge at his organization. At my organization, we kind of have not an advisory board, but it's just like some people in the data team and some people in IT trying to work for our broader functions, but we don't have anyone looking at it from a more holistic level. It's just, what are the initiatives we are doing in the next year or two? And how do we get things ready for that versus how do we want things to connect in 3 years, 5 years?
We would expect that to happen as soon as possible, right? I don't know if you're talking about a mature company or a startup, but for a startup, I would say start as early as possible because that will determine whether you will be able to scale or not. The sooner you draw that strategy for data, the better you are able to scale, right? So a lot of companies nowadays, they understand the value of data. And if you don't build the infrastructure to support your need to harvest and store and manipulate and extract insights, and you might pay the price later. And that strategy is going to depend on whether you want to build this infrastructure in-house or you want to leverage, third-party service providers. And it depends on the cost. The money that you have to spend on that infrastructure and everything else. So you would want that to be a part of the company's culture. That's the ideal space, in my opinion, and to start as early as possible.
So Austin says this is a semi-mature company that's been around for over 100 years in manufacturing, but is catching up in data strategy. That sounds eerily similar to the situation that I'm at work, being at a manufacturing company that's about 100 years old and catching up in data strategy. But I don't know, like, I think I'd love to hear other people's perspective on this. Maybe Joe or Brandon, if you guys want to chime in. But like, I know some companies, like even the old startup that I was at, Bold Commerce, the data team was under the finance group, right? And right now, like, the data group is under the CIO where I'm currently at. So does it make sense for a company whose primary asset is not data, who's not in the data business, to have a chief data officer? Should that role be for somebody that's like a CFO or a CIO? Like, I'm not sure.
I'll say it, George. Don't worry. Why isn't data their chief asset?
Well, I mean, that's a great point. Like, if you're in a manufacturing company, like, the product that you are selling, that you're making money off of, is like a tangible good. I mean, I could be getting canceled here very soon. But that's just what I'm thinking about it. Yeah. Joe, what do you think? I'd love to hear from George on this too, actually.
I'm going to read some excerpts from John Thompson's book about this. And he's got a good take on this, and I'm not going to reinvent the wheel. I was about to write an article on data teams, and then John hit me up, why don't you just read my book? And after I read his book, I was like, I have nothing more to say on this issue. But, you know, what he writes: to start their journey, many companies will hire a chief data officer who has experience and a taste for analytics to address the most common data hygiene issues while delivering analytics outcomes. Over time, the role will change to more of a chief analytics officer. And so he defines a CD role. It's about data management, data governance, data security. Certainly for larger organizations, the chief analytics officer is about extracting and delivering business value and economic impact from data using analytics, data science. So I think it's a good way of delineating the two roles as well. And then maybe that would be a good litmus test to decide which one you'd want to hire. I know John's book focuses on analytics teams. I think it's more in favor of a chief analytics officer as opposed to a chief data officer. But in either case, the reality is, you know, chief data officer is a role that is becoming more common, especially in larger companies. But I think John's would also probably agree that the CEO is actually our chief data officer at the end of the day, right? The CEO needs to take charge with the data. If you don't have the support of the CEO, I don't think anything's really gonna happen. So,
yeah, George Perican, I'd love to hear from you on this. I mean, like, kind of coming from like the role where you're at, you're director of data governance. Like, to me, that almost sounds like it's kind of what a chief data officer would do. Am I mistaken? What are your thoughts on this question? I'd love to hear that.
Yeah, so I agree with what Joe said, that really the CEO should sort of own that data piece, but in terms of they should sponsor it. And then I guess depending how data savvy they are, they might want to offload some of that responsibility to a CDO instead. But even so, yes, they should always be behind it and be the ones that help secure that ongoing funding and support and help really promote the importance of data as an asset throughout the organization.
Awesome. Thank you very much. Man, these are good questions. Would anybody else like to add in here?
Just to also echo another thing that John was saying in his book, you know, the chief data officer or your chief analytics officer, anybody dealing with data should report to the CEO, period. Not the CTO, not your CFO, God forbid, the CEO. End of story. I've seen this go awry where the head of data goes to the CFO, and then you just start being accountable to the finance department, and that sucks.
Yeah, would never want to be accountable to the finance department.
No.
Yeah.
Well, while we're talking about data assets, do you guys think like companies like kind of like older companies, mature companies who have data on premise, are they behind? Is it the general understanding that they're behind with regards to, you know, companies who are on the cloud, who adopted quickly and things like that when it comes to data science, AI, and things like that? I don't really hear about that, thinking about it now.
Crickets. Stump.
Is that actually my kid blowing a whistle in the background said that?
No, I was saying like companies who are like older, mature companies who are on premise, who have their data on premise. Does it mean that they're behind in AI, data science, and things like that? Or, you know, because typically when I hear a company who's like very hot with AI and things like that, they're very, pro cloud and things like that. So, but I don't hear the stories of those who are fully on premise and they understand the value of data, but where are they on the spectrum of AI maturity? What are your thoughts?
So just give a little anecdote here. Like my company, put a model into production. It's in the customer facing system right now, delivering lots of value. All of that was done with data that was on premise, databases that were on premise. But I mean, everything that we have is like everything's happening on Azure in terms of the deployment and everything like that. But I guess the data is still like they're on premise databases.
I mean, cloud just means you're shifting your operational footprint, right? So you're just moving it from like your data center to the cloud. But it really comes out of a set of practices. I mean, look at like high speed trading firms and stuff like that I think are really algorithmically sophisticated, but probably have on-prem just for a lot of reasons, right? And so yeah, I think it's. But Matt and I always call these dark matter companies. These are companies that are on-prem. You never hear about them. They're making a shit ton of money, running Windows usually. Like just all the stuff you would think is like highly unpopular. Like they're just killing it. And so, yeah, it's a good question. I mean, we see a lot of clients. I think there's quite a few that are doing wonderful stuff, even though they're on-prem. They're certainly not going to get the attention though, right? Because I mean, these companies are probably less likely to toot their own horn about what they're doing because like, what's interesting about a company that's running some like crusty data center stuff, even though they're probably making money in like a startup in the cloud, right? So
yeah, and I know there are some products like Snowmobile, Snowcone that AWS offers that companies who are remote, like those oil rig companies who want to transfer petabyte of data to the cloud, and they send a truck to your facility to transfer that data and bring it to a data center. I think that's pretty cool. And I guess they're trying to make things easy for them, but does that change their, flexibility in terms of adopting AI or data science and things like that? I don't know. I was just curious.
We have a lot of companies clients that are on-prem still. And I mean, some of them are migrating to the cloud. In fact, in Salt Lake where I live, Google just opened a data center like down the road where one of our clients is actively moving their on-prem workload into the cloud. And I think the challenges that they're going to have really is that they can't operate in the cloud like they do on-prem. On-prem, you can just leave your servers on all the time. You really have to know what you're doing with the cloud in order to make it effective. That requires just a complete change in your practices. It can actually be a total disaster if you're not careful. So you really just need to understand how the cloud works, how it wants to do stuff, and play by the guardrails there. But what it would give a company, I think, is more flexibility and agility in terms of experimenting stuff and not having to be so cumbersome by their encumbered by their infrastructure. But you see companies saying on-prem, or for some reasons, like one of our clients, they got bought by a private equity firm, and so their metric is like EBITDA, right? So guess what's going to make EBITDA look better? A capital expenditure where you're depreciating your on-prem assets over time, right? Because if you your expenses over time, if you were to suddenly go to an operational expense model like the cloud, well.
Yeah, it's going to be fussed at. Yeah, absolutely. They love depreciating assets. Definitely. I see what you mean there.
So it just depends on what's motivating you to. Like this company, we told them, like, look, you're going to probably make more money going to the cloud because you're just going to be a lot more agile. But, talking to, the CFO was like, well, yeah, except we already know what our model looks like here. The cloud means like, and this company has like 40% market share in its respective category. So I mean, it ain't going anywhere regardless. I mean, they could basically just like fall asleep for the next 5 years and probably still make money. So, just depends. So
yeah, makes sense. Thank you.
You had your hand up a couple minutes here, Tom.
It's just a historical perspective, kind of thinking, okay, what other STEM areas have been through this? And I love to think about the electrical age, which didn't really begin that long ago. And I think they went through similar growing pains about perspectives and such. Let's remember Tesla studied from the mechanical engineering department. Isn't that hilarious? We're still feeling out specializations in this space. I think organizations are still wrapping their head around what's smartest to do. But Joe, correct me if I'm wrong, I'm also a big fan of John's book. And my takeaway is that chief analytics, data science, data officer really needs to be reporting directly to the CEO. And it's a spirit of, yes, he shouldn't be under any other chief but that one, but he should be, or she should be working very closely with the other ones. Because to me, data science is to serve the prophetic or the truth needs. The truth investigation of the organization should be data-driven, data-centric. But I think we're going to feel these growing pains. And you're right, Greg. This discussion is painful. It's just painful.
Austin, you've caused this all some pain.
I'm sorry.
So Russell, you had some great comments here as well. I'd love to free that up from the chat if you want to give us your thoughts here.
Okay, sure. Well, the most recent I've put in there, I'll talk about because that's freshest in memory. And it's just building upon the difference between on-premise and cloud. So I've, in my time, worked with building a lot of data centers globally for some independent co-location providers and some big blue chip clients. And they have exploded for the last, say, maybe 20 years. They're just going everywhere. And there are environmental concerns with them. There's a big power drain on them. The cooling of the server is basically the biggest cost for those at the moment. So there's a lot of work to do with those to make them more environmentally friendly and hopefully protect the cloud environment for us. But I said I wrote a little piece a little while back saying that the ultimate adoption of the end user could be that we all start using dumb terminals. So our interface with everything is not a laptop or a PC, but it's a keyboard and something, but it has no local CPU capacity other than is sufficient to connect it with a hub, with the network, with the data centers, etc. And all of your processing capacity, as well as data being stored, is done remotely. So that the devices you buy, much less complicated, much less costly, but it does require a lot more investment in the data center infrastructure. And the biggest restriction on that is firstly space to build all these data centers in a place where they can run efficiently, and then also these environmental concerns. So the heat output from the CPUs, when multiplied thousands of times by the number of server racks these guys have, there's a huge heat output. So cooling for those is a big draw on the electricity supply. So yeah, a lot to think about, but yeah, it's something that I think will happen probably in 15 to 30 years as a guess, depending on how the technology progresses. The one thing I'm really keen on seeing how this develops in the data center world is the processors themselves. I know, I think Intel were talking about processors that created much less heat output, fix the source of the problem rather than get better at dealing with the heat output, just make it less. Liquid cooling is also becoming really big in that field. And the last thing is quantum computing, the actual chips starting to use quantum computing. That's fascinating for me. Really can't wait to see that come into action.
Yeah, I'd love to get somebody on the podcast to talk about quantum computing. If you guys know anybody who's written a, kind of a friendly book on that topic, please let me know, shoot me a message. I'd love to get somebody on the show to talk about that because that's super fascinating stuff.
Just one quick thing back on that, Harpreet. They've probably already done it. We just need to find a bit of a quantum joke. Sorry.
So above my head here.
Neither here nor there, right? That was also fun. Yeah, it's interesting in Utah, right? Because we're in the desert. And so I think within about 20-minute drive, I can see the NSA's data center, Facebook, Google, and I think there's a couple others being built right now. So I find it interesting, right? Because water is supposed to be, and cooling is supposed to be an interesting thing, right? Useful for data centers. And yet they built it in one of the most arid states in the union. It's totally crazy. I think it just has to do with the tax subsidies that they got or something, because the legislature here really doesn't give a shit about the longevity. So I thought that was kind of interesting.
That's pretty funny. Right on, guys. Well, we'll go ahead and wrap it up for today. Thank you so much. Such great questions. Thank you guys for sticking around till the end. I really appreciate having you guys here. Remember, next week is the 1-year anniversary party. I can't believe it has been 1 year since I launched the Artists of Data Science podcast. I remember reaching out to Brandon before I even had a podcast. I was like, please come on my show. He's like, well, you don't even have a show. But he agreed to come on the show anyway. So thank you for coming on. But yeah, next week is the 1-year anniversary party. Got the episode releasing with Robert Greene, which is one of the interviews that I'm most proud of, mostly because Robert Greene said that was the most interesting interview he's ever been on. And Robert Greene has been everywhere. So that's pretty cool. A lot of awesome stuff happening, throughout the remainder of the month. speaking to Dana McKenzie, co-author of Book of Why. So I'm super excited about that as well. Don't forget to register for Data Science Go Virtual Conference, where yours truly will be the Master of Ceremonies. Greg will be presenting there. So will Susan Walsh, a lot of other people as well. Check out the interview that I did with John Crone on Super Data Science Podcast. And yeah, man, looking forward to seeing you guys next week. And, hopefully everybody has a drink in hand. Tell all your friends. Let's get 100 people into this room. That would be awesome. If you're listening at home and you have never came into an office hour session, now is the time. You got to come next week. Come next week for the 1 year party. Albert's joining in right now, right when we're about to shut it down. But yeah, next week, 1 year anniversary party, guys. Looking forward to seeing you guys there. Take care. Have a good rest of the evening. Have a good rest of the weekend. Remember, you've got one life on this planet. Why not try to do something big? Cheers, everyone.
Great convo. Thank you.